Today I'm going to talk, have the title to log or not to log. That's the question, inspired from the Shakespeare code. First, a quick intro of myself. I'm Amirhossein Aliakbarian, call me Amir. I'm an application security engineer at Booking. With MSc, as I said, in cybersecurity. I was a lecturer in the university and also, with lots of, maybe this is better, with lots of experience in every single field in the computer that I was able. Okay, and a bit about Booking Holding. Booking Holdings Center of Excellence here in Bucharest is a part of Booking Holdings, the world's leading provider of online travel and related service with a rich heritage of digital innovation. The center provides access to highly skilled talents across the brand to provide different services for all the brands under the Booking Holding, which consists of the Booking.com, Kayak, OpenTable, Agoda, Priceline, and rental cars. The Center of Excellence currently provide core cybersecurity, fraud monitoring, IT infrastructure, and procurement analytics. And also it's going to provide more services toward this year and the next year, such as data governance, finance, and marketing. Okay, in this meeting, we will first have a talk about the motivations of logging information. Just to make it clear, I'm mainly focused on logging in the web applications. And I will, as I said, give some motivations of why to log. And then some challenges of logging, especially when we are dealing with some larger scale enterprise and having lots of requests and logs. Then I will give some real example of things that might happen with logging inappropriately. And finally I will provide some of our experiences that we had to implement such a solution in enterprise. One of the most motivations of logging is for the debugging. Developers want to log some internal states, variables, decision trees, input, output, and errors and warnings to be able to debug the applications and to find the edge cases and any problem that might happen during the real-time running of the applications. Also, there are some security-related usage for logs as well. For example, logs can be used for intrusion detections. Different detection of malicious input and output based on signatures or some patterns can be implemented. For example, looking for malicious inputs such as injections and also working on the outputs. For example, whenever some errors has appeared in the output, that can be a sign of some problems. So this can be also used. Also, anomal detections can be run on the logs to find malicious behavior. For example, if we are facing more than normal errors in a specific time window, then it seems that something is going wrong. Or if for example, request sizes, the response sizes are bigger than normal, maybe there is some data breach happening. Also, if we have logs, we have low-level logs, we can then correlate them to have some higher-level overview of the application and what's going on, and run more services and works to find out what's going on. One of the core reasons of using logs are the incident response process. By having logs, whenever we have enough logs and some incidents happen, we can look for known attack vectors that are already used to find out the real exploit attempts and the real breach that we have. Also logs can be fine to identify the attacker, to find I don't know, the IP address or any other information that can help us to identify the attacker. But by using logs, we can find the real leaked data. If we have good enough logs, we will be able to find what data that we have been leaked during an incident. Also, we can trace back to the root cause of the incident and the real exploit points that the attacker were able to enter our system. But logging and collecting and producing log is not trivial. There are different challenges when we are deploying such a solution. Well, logs may contain sensitive data because the request contains sensitive data. All the requests that coming might contain, I don't know, username, password, email address, physical address, credit card information, authentication information such as username, password, or authentication tokens. And they're coming, and if we just log them, log everything, then we will have those data stored somewhere that are not supposed to be there. So maybe we can try just to stop logging this kind of information. What if we do not just log, I don't know, passwords, for example? The problem is that it is not so trivial to just detect this information. Let's say this is a similar issue with finding the injections. If we were able to find where the SQL injection or any other injection coming from, we could just block them or, I don't know, fix the issue there. But this is also the same case. If we were able to identify where the sensitive data are, we could just stop logging them or do something with that. But it is not so trivial because the sensitive data appear in every places, like in the query parameters, in the body, in the headers, in any internal states, in the variables that we are logging for debugging, and so on. Also, if we stop logging sensitive information, it will also limit us during the investigation. For example, if we want to identify the data that are really breached and we have just not logged those data, then we will be stuck there and we will not be able to find the real data that have been breached. The producing logs is also not so trivial. We need to know where we should produce the logs. We can think about some web server, the entry point that a request is coming. So every request are passing through that point. So we can just log everything there. But one of the main problems is logging in the web server is that we are missing the context. In the web server, in the entry point, they do not know what the request is about. What does the parameters mean? What are the real parsed value of the parameter? So we really miss the context, and this can be not so good in logging. We can log by the applications itself in the code bases. There we know all the context and all the domain information, so we can just log there. But the problem is that there also might be missing some information there. For example, some information related to protocol might be missed there. If there is a load balancer in front of the applications, the TLS connection is already terminated there, and we do not have TLS info or other client-related information. Also, it's going to be a bit hard to manage, change, and standards or the logs that are being logged. Because there are numerous, in a larger scale company, there might be hundreds of different teams and applications that they might own their own way of logging, and it's going to be a bit pain. Also, we do not have the real database operations. We might not have the real database operations that are being run in the application because there might be another layer of the data access layer that some of the data might be already dropped or I don't know, is not completely visible by the application itself. We can go to the data access layer. It's again a single point that we can just log every data that have been accessed or touched or changed, but it also have its own problem. Again, it do not have the real context of the request, real context of the application, that what is it about. And also, yeah, maybe we are just over logging there, just logging everything and every single accessed row or a cell that might be a bit producing a lot of data. That's not always the best way. The next challenge is about delivering the logs. And we have generated the logs. We can think about something like 1 billion external requests that coming to the server. And normally most of the services are using somehow some service-oriented architecture. They call some internal requests as well. So yeah, we can add 2 for each request. So we are dealing with something like 3 billion requests a day. And yeah, that's not a small number. We are not going to store them. We are not going to store them locally. We probably want to store them in a central place that we can query and we can look over there. So we are going to send them over the network again. So we are producing more network traffic and more network congestion there. And then there are lots of logs. We want to store them. What we want from a log, we normally want the details of the request, some internal states, and some variables. The details of the response size, the headers that we are sending to the user, also errors and warnings that are happening. We are eager to have them. We can consider something like 2 kilobytes for each log. Then we had about 3 billion logs. It's going to be 6 petabytes per day. And yeah, we are not going to just store logs for 1 day. Yeah, for example, for some compliance reasons, we might be needed to store logs for at least 6 months. So it's going to be something like 1 exabyte of storage, which is too much. And yeah, then we want to use them. We want to analyze the logs. It doesn't make sense to just have the logs laying there. You want to do filtering, filter by a specific IP address, filter by, I don't know, the ISP or any other information. Also, you might want to pivot data based on a specific criteria and specific parameters. You also are eager to do some aggregations. I don't know, top 10 IP addresses, top 10 requests, maximum response size, average response size, or this kind of information. To be able to run this, we surely need to index data. And by indexing data, we need more and more storage. This is also access control over the logs is also a problem. Not all the data that are stored on the logs should be accessed by everybody. Some of the information might be only valid to be accessed by the developers, for example. Errors and warnings might be only needed to be accessed by developers. Some others, I don't know the source IP, some sensitive information might not be accessed by developers, but some security experts on a specific condition. So we need to have very granular access control over the logs over the time. It is not such a simple, just a simple storage. Also, the logs might be used by some services or some users and stored in other places, and that's also going to be a big problem. The data might be leaked in other places as well. Then we can go to some examples of the logging, the bad loggings that might happen. As I said, a normal login page can just have a request like this, an email, a password, and some other parameters. If we just Log the password, log the request bodies. We will log the passwords everywhere. And yeah, it's not the things to do. Also, the credit card information might be exist in request. It is not only the page that get the credit card that is sending the credit card for storing. Lots of sites, lots of websites and services use some JavaScript, for example, to store the current state of the page. So if you come back again to the page, you have all the fields filled, and you can continue with that state. If such a script is exists in a page that gets credit card information, then the credit card information might be already sent to the server in an endpoint that is not supposed to get credit card. So it's not so trivial to just keep track of the endpoint that are supposed to get the credit card. Also, this is not a good but common practice that, especially for mobile and API endpoints, the programmers send the authentication tokens via their request parameters, something like this. And so, yeah, they are being logged in everywhere because they are existing their request and they can be logged. Authentication tokens are somehow worse than passwording sometimes because it is also a common practice that by changing the password, the systems might not expire the token, or might not expire the authentication token. And for example, if you change your password, your mobile application might still be logged in because it's a bad experience that might the user happen. So yeah, they are not doing this lots of them. So in some terms, authentication tokens are more dangerous than passwords. So yeah, the best practice is just to send the tokens with the headers, but again, headers are also some users' inputs, and if you want to log the user input, we should log the headers as well, and yeah, we'll log the headers there. So we need to take care of that as well. We need to look at okay, all the headers should not be logged. Also, one important things that happen with the log is that normally the applications that are directly dealing with the user inputs are more considered as have a better security looking. So developers and I don't know security experts have more eye on that to make sure that the user input is sanitized or do not have injection or something like that. But this data, if you use logging, this data is going to be rest, is going to be stored somewhere, and sometime later it's going to be used by other applications. And because that application mentally, developers think that, okay, it is not going to work on the user input, they might be not as secure vision about over the sorry, they might not have enough secure vision over those applications, and it can be lead to some blind injection in the loggings. Okay, now I'm going to based on some of our experiences that we had in booking to provide some basic structure, really high-level structure that we are using in booking to have a better logging ecosystem. Yeah. This is the really high-level overview of what we have. The client sent a request to the server, to the external load balancer, let's say, the entry point of the application, the whole ecosystem. The external load balancer, I say, will assign an ID to the request. It can, then it will pass the request to the real application that is going to handle the request and process the request to generate the response. The application then, after processing the request, will, and before sending the response back to the load balancer, will send a log with the ID 1 to the a place in a stream, let's say a Kafka topic or any other streaming event streaming ecosystem that you can take. Then the external load balancer will just accept the request, the response to be sent back to the user if the ID exists, if a log with that ID is already sent to the topic. So each application is mandated, each service is mandated to at least write a log to be able to serve externally or internally, to be able to serve a request. By this, we can make sure that applications are doing logging. Also, if the application is going to contact some internal services, as we thought, with some structural like service mesh or any other architecture, the application will send it to another load balancer, and the load balancer will do the same. They will assign a new ID, let's say ID2, to the request, and pack it together with the ID1, which is the parent ID, and send it to service 1. The service will again process the request, send the log to the topic, and then get it back to the load balancer and all the way back to the client. So with this structure, we are making sure that first, as I said, every application is doing the log, is logging something for each request. Then, by having this parent ID over the services, we are correlating the different requests, the different logs together. So whenever we have an internal request on one of our internal services, we know that it is triggered by what external request. Then it will be consumed by different services and different storage systems that I will get back to that as well. One problem here that we mentioned is about the producing the logs and the way that the application should produce the logs. We need to define a standard, a practical standard for the service owners, for the developer teams, to make sure that they are generating the logs and generating the data that we as the security, as the application security team want the data. So we had defined a standard and work together with the service teams to make sure that they are able to provide those data. A standard should be practical. It's not a good idea to just send a standard, write a standard and send it to be applied by everybody. We need to make sure that it is practical, and teams can make sure we can provide those data and exactly provide the data that we are looking for. Then we also need to make sure that the produced logs are compatible with the standard. We need to make sure that the logs met the standards. So we need some compliance metrics. We need to have a look over all the logs to see that, okay, we had make sure that for every single request there is a log, but does those logs really contain the information that we want? So we need some compliance metrics over there. It is not a good practice to make it strictly blocking. If an application is not providing all the details that we want, just block the request and not serving to the client, because it might be in lots of reasons that is happening. And it is not a good user experience to just block lots of requests because of some internal error or some things that can be temporary bypass. So we made it as a synchronous way. The data that were coming to the topic were stored somewhere, and we had some graphs and some compliance metrics over these data that can be reported to the different stakeholders, such as the developer themselves, the owners, the directors, or anybody who is interested in those data. And if a service is not compliant with the standard for a while, it can be a red flag, maybe it got blocked, or any other action that is required. We need to have some graphs, not like this one, probably, but yeah, with some kind of graph, we can make sure that the applications or the services are compliant with the standard. To be able to implement the data, because if we are talking about the web applications, there are lots of common things in the web applications that can be shared among different services. The IP address, the request info, query parameters, headers, these are the common data that every single applications need, can provide and need to provide. So we work with some, our framework team and some, they provided some shared libraries to produce those data, the basic information, the structures of the data, and also some scrubbing of some sensitive information. For example, the credit card information for sure is not going to be logged, and it have a specific structure. So by the underlying framework and the shared library, we can just scrub this data and prevent them from being logged. Then we need to work with every single service to make sure that they are providing the specific business-related information. For example, in our case, the hotel ID, the hotel name, this information that are related to a travel, that are related to a request, can be provided in the logs in the best way. Then as of delivery, we said that our main delivery infrastructure was a Kafka topic, but we decided to have another layer over there. That is we call the event system, which is getting the logs from the applications, but before sending them and writing them directly to the Kafka, it will do some processing on it. First, it will look for the private information, the PII or other sensitive information. We use mapping. We can use a mapping of the PII and have, instead of the PII themselves, have some IDs for them to be logged in the loggings, in the log storage that we want. Then someone with access to the logs cannot have access to the PII information, the personal identifiable information, but they map to exact one specific PII. If for later use it was needed to access those information, if we wanted to know that, for example, as I said, there's a data breach, we want to know what users have been breached or what data have been breached, we can just remap again to those data. And these PII mapping database are stored securely in the with granular access control. Also, some scrubbing can be, again, implemented here if there exists any credit card information or any other sensitive information that can be scrubbed. Also, there are some other sensitive information that might not be accessed by everybody or by developers especially. We can just separate this data to another place with another access control. So we will have this data separated and with different access control here. Then finally, not finally, but when we want to store the data, we can do some enrichment over the data. It is not, the enrichment of the data is sometimes time consuming. When we want to generate and extract the geo IP information of a single IP, or attach some threat intelligence information about some IP or some request or anything else. Also to correlate some information. For example, if we have a hotel ID, we want also the hotel name to be attached there. There are some information that even they can be produced during the producing of the log by the applications, but they are not but they are time consuming, so we can do it later. So before storing, we are doing this to make sure that the applications are returning in a faster way. Also, if needed, for some specific use cases, those PII data might be retrieved and mapped with the the anonymized ID and stored in a secure place if needed. Also for some use cases and for specific data especially, we can use sampling data. I don't know, store the data 1 in 100 or something like that to make sure that reduce the storage cost, especially for some analytical data that we want to produce. We can run some analytics over the sample data, so we can make some statistics over the data with sampling without almost losing nothing. And yeah, finally, to be able to use the data, we had different storage systems, some short-term, heavily indexed, and really granular data that can be queried and filtered near real time with seconds of the response time, with shorter retention period, something like 2 months. And we will store the long-term data for 6 months or more in a cold storage, which is way cheaper, but the data there is not so well indexed, and retrieving the data is more costly, but it is needed once in a time, and yeah, the cost can be reduced by this size so much. Also, we can use, and we have used some distributed tracing solutions to be able to just go over different logs and correlate logs based on different parameters. The base parameter that I have mentioned is the parent ID of the log, the log tree of a service that is coming different through the different services whenever a request comes. But other than that, it can be used to correlate data based on other parameters as well, to make sure that we will be able to analyze the log all over the places that a request is coming and going. Yeah, I think that was much it. And yeah, the whole idea of us is not to end up something like this, that the logs exist, but we cannot find anything from them. Thank you. If there's any question.
Are there any questions in the audience? Can you find folks get a mic over there, please?
Hello. So you said earlier that you are storing 6 petabytes of data per day. And I was curious, what solution are you using for storage and discovery of the logs? Because as you said, logs don't show nothing.
As I said, this amount of data is if we use some, let's say, stored raw data for all the logs. But yeah, for sure, we are doing compression. These are the text logs. When you use the compression, it will be, I think, 1 in 10 or 1 in less.
Still, it's a lot of data.
Yeah, but still it's a lot of data.
So if you want, for example, use the Elasticsearch for, I don't know, for discovery, it's capable, Elastic or Splunk, to do the analysis of the logs?
Yeah, as I said, for short term, yeah, for 6 months, it's not going to be capable of doing that.
I mean, for 1 day, 6 petabytes of data
for those amount of data, yeah, almost yes. Also, I think I'm afraid that I cannot give more information about the underlying systems, but yes, for those amount of data, we have some solutions that we did.
So you are using a proprietary solution for this?
Yeah.
Okay.
Yeah,
oh, I was thinking which one it's much more, so if between Splunk or Elastic or other solution. Okay, thank you.
Yeah, no worries.
Can we also get a mic on this side of the room, please?
Okay. Thank you for the presentation. So I know that logging is a very important thing, right? But it is also very expensive, especially when companies want to just take them for like 6 months or more, right? So in your opinion, what kind or what type of logs are the most overlooked in companies or not logged?
Or not logged?
Are not logged, yeah, not
Okay,
logged or overlooked.
Well, you know so some information that are normally not logged are the big chunk of data which are most expensive to store. For example, I don't know, their responses or the request bodies or the errors. These are the data that normally might be bypassed by logging. And yes, so some of them can be regenerated. For example, if you talk about the response, the real responses, it might not be really needed because we know the input, and if we have the state, we can, if needed, regenerate the status. Yeah, the ones that are overlooked.
Now, I know it's a wider question, like there are many answers to this. I just wanted to know your opinion.
Yeah. I think that the most important things that should be stored and should be logged are, the core things that have the parameters and these informations, and being able to correlate them, having some specific place to correlate and aggregate on these specific things. But it's going to be a bit lots of storage and lots of cost to, for example, have a space each. Let's say, a parameter index individually, query parameter or header index individually, it is very costly thing. That's, normally we are not doing that in the first place. We will try to make it the minimum. Then, if needed, we will run again on the raw logs to extract these and to index these and be able to do the filters that we want. But here we will have less useful data during the runtime.
Yeah, I just wanted to ask this because sometimes people just realize they don't have the logging that they need in place just after a breach, right? Because you don't find what you need.
Yeah,
so that's why I wanted to know it. Yeah, thank you very much.
Hello, here. So for sensitive data, let's say, do we have redundancy backups? For sensitive logs and data, do you have, for the proposed solution, backup redundancy?
Yeah.
Because you didn't mention, so I was just curious.
Yeah, the redundancy is also there for every single data. It should be exist.
Hello, thank you for the presentation. Do you have any recommendation for, I don't know, frameworks which are space efficient for, let's say, embedded devices, or strategy for logging for embedded devices, where, I don't know, you need to put all the logs in 100K?
Sorry, I didn't get your question.
Frameworks which are optimal for embedded devices for logging. Very tiny storage.
I'm afraid that, no, I don't have any experience on the embedded devices and those kind of things.
Okay, thank you.
Yeah, sorry.
All right, thank you so much, Amir. Thank you, everyone.